Hello everyone, welcome to our pre-calculus class. This is our lesson 9, solving equations involving a single trigonometric functions. This is from section 7.3. Okay, these are the agenda. Solution of an equation, what does it mean? We will discuss it a bit. Then checking whether a given number is a solution of a trigonometric equation. So this is like how we will understand which one is a solution of some given trigonometric equation and which one is not, that kind of math. And then finding all the solutions of a trigonometric equation, 1 number to 3 numbers. So there are like a couple of steps there in class practice and homeworks. So these are the agenda. Let's look. First of all, what does a solution mean? What is this? What is the meaning of this? Let's say if we say that uh, from this given equation, if we say minus 1 comma 0, is this point is a solution of this equation? Then let's say if I say 1 comma 0 or 0 comma 1, is this a solution of this equation or not? How we will understand? So I think you can see it here a bit, and that is, if this ordered pairs, if they are the solution, then they will fall on the straight line. So suppose this point is a solution. This is the equation of this line. If you graph it, this is the equation and this is the graph. This is the straight line that is represented by this given equation here. So if some particular points are the solution, suppose this point, many points, there are tons and tons of points. We are taking just only integer points, but you can take decimal number also. So this point is a solution, 0, 1, minus 1, 0. They are the solution of this given equation. But if we say this point, 2, 1, so 2, 1, this 2, 1 is not a solution of this equation, or this 2, 1 is not a solution of this given graph because this is outside it. Now, how we will understand it from given equation? And that is, we understand it if we put the x value in the question, we will get the y value as answer. So if you put minus 1 here instead of x, so this is minus 1, then you have plus 1. So minus 1 plus 1 equals to 0. That means you get the second value of the equation. This is how we understand it. Similarly, now if you put this thing, okay, let's check if this is valid. X plus 1, y equals to. We have written it in the equation and function form, both form, but calculations for both of them will be similar. Now if we put 2 here, x equals to 2, this value, x equals to 2 is this value. Then we have plus 1 here, this plus 1, so total is 3. That means 2 comma 3 is the solution of this equation. This equation solution is 2 comma 3, not 2 comma 1. This is not correct. This is not a solution. So it means if some points they represent the solution of the given equation, then they will exactly match from our given equation. Their answer will match, their coordinate will match with each other. And you can always put the x value and then you will get the y value. Or if you put the y value, you will get the x value, vice versa. Okay, so they will give you the answer always. So, and you can see there are tons and tons of points. Actually, they are the solution of this equation. There are many points. They are the solution of this equation, all on the line. But also, this is also true. See the other side of the coin. There are tons and tons of points outside also. They are not the solution of this given equation. So there are many points that are not solution, and there are many points that are solution. And in fact, there are actually infinitely many points on the line and even outside in both cases, we can say. So this is a simple example of the solution meaning. Solution means that the point will actually satisfy the equation if they are the solution. Okay. Now we can actually put this same thought process, we can actually continue the same thought process for our trigonometric function. Say here two values are given. One value is theta equals to pi by 4, and then another one is theta equals to pi by 6. Two theta value is given for this given function, and the question is theta equals to pi by 4. Is it a solution of this equation? And theta equals to pi by 6. Is it a solution of this equation? So this equation is 2 sine theta minus 1 equals to 0. This is the equation. And what does it mean is, it means that if you put this theta instead of this theta, then your left hand side and right hand side should match. Let me show you, then you will see. So 2 sine theta, we are checking this value first. Theta equals to pi by 4. So if you put pi by 4 here, pi by 4 means 45 degree. So sine 45 degree means sine 45 degree means 1 divided by root 2, or root 2 by 2, you can say that also. Let's write root 2 by 2, that's better. That's better. Root 2 by 2, then minus 1. Then if you do the calculation, we will not write the other side. Oh, we can write also, that's okay. That's okay. 2 cancel out, then we have root 2 minus 1. If you write the whole thing, that is also fine. If you write the whole thing, this equals to 0, this equals to 0. And now you can see that from our left hand side, actually this is not equal to 0. Root 2 minus 1, this is not equal to 0. We know that these two, they are some digit, they are some numbers, and if you subtract it, they will never be 0. Now on the other hand, let's look at this value. So 2 sine theta pi by 6. Pi by 6 means sine 30 degree. And sine 30 degree value means 1 by 2. Then minus 1 equals to 0. Then 2 cancel out. You have 1 minus 1 equals to 0. And you know that this is equal to 0. So this equals to 0. So when you see that your left hand side and right hand side is matching, that means this thing is a correct solution. This thing is a correct solution, and the solution for theta equals to pi by 6, this is actually a correct angle for this given equation. This is the correct angle for this given equation. In other words, we can say that this is not a solution. This is not theta equals to pi by 4. It's not a solution for this given equation. This one is, because this one is satisfying the given equation. This one is not. If you put this, then actually they give us different answers. It's not giving us the correct answer. So this way we can prove it. As I said in our previous slide, we said that if you put the value, then you should get the other answer. So if you shoot the value of theta, you should get 0 here. We should get 0 here. Or we can send actually this 1 to the other side. Then we can try to check if 2 sine theta gives us 1. That way also possible, but all similar thing. So the rule is, we have to, for checking, we can just plug in the value in the given equation. Then we can check if left hand side is same. Then we can say that they are satisfying, they are correct, or else they are not. And you can see here, this is a proof that our solution is correct. So this is the value. This is the value, pi by 6. So pi by 6 equals to 0. This point is actually on the equation. This point is actually on the equation. When theta equals to pi by 6, then you get the graph of this equation. So you get it 0. Pi by 6 equal to 0 for this pi by 6. And then next 0 is 5 pi by 6 comma 0. Next 0 is, and the previous 0 is 7 pi minus 7 pi by 6 is 0. I'm just showing you the graph. If you draw the graph actually, then also you will see what is happening in this given equation. This is just to show you that they are going in the right direction. This is what it means. See, pi by 6, when you put pi by 6, answer comes 0 in this given function. And since this is a sinusoidal graph, there will be many solutions. As you know, sinusoidal graphs goes on forever. So basically we will have many solutions, but they are asking like this one and this one, only two they are asking. Yeah. And from this, actually, you will understand that 45 degree is also not a solution. Suppose 45 degree will be somewhat here in the gap, so for 45 degree it is not 0, so it is, you can see that also. Now we'll try to find out the value of different all solutions of a trigonometric equation when cos theta equals to half. So cos theta equals to half, where is it in our unit circle? Cos theta equal to half. Where do we get cos theta equals to half? From our standard values, there are some standard value that we know, like sin 30 degree, cos 30 degree, sin 45, cos 45, sin 60, cos 60, then 90. So 30, 45, 60, 90. These are the very standard kind of value that we always refer to while solving it. So this is that unit circle, and cos theta is pi by 2. We have it at which angle? Think about it. Where we get it? Sin theta pi by 2 is sin theta equals to half. Just if you know the sin value, sin theta equals to half. Sin theta equals to half is at 30 degree. Half, this is at 30 degree. So cos theta equal to half will be at 60 degree, because they just come from the reverse order. This way also you can understand. And 60 degree means pi by 3. 60 degree means pi by 3. That means cos theta equals to half. This is at pi by 3. If theta equals to pi by 3, then you have cos theta equals to half. You have cos theta equals to half if theta equals to pi by 3. If theta equals to pi by 3. Now, from our unit circle approach, you can see it here also. Let's not draw it. You can see it here also. So this one point, actually, if you look, there will be some more reflection of this point here, and then here there are more points also if you want to draw. At many other points, actually, it will be, suppose this point coordinate will be what? This is minus half comma, this point will be minus half comma y value is something here. We actually know what is y value, but we are just not writing it here, that's it. And this point also we know it will be minus half minus y, minus half. I mean, some of you may have the question like, sir, why in the book they have written only these two value, why not this value and this value? Because this is negative, see, this is minus half, this is minus half. If your question is how do we get this value, we get it from the reflection. Y-axis reflection, this point y-axis reflection is here, and this point x-axis reflection is here, this point x-axis reflection is here. Because if you think about the symmetry, that way we can actually get this point. Always, for every point we can get this kind of symmetry. So we have two solutions of this question. One is at 60 degree. Another one is, actually, if you come all the way up to here, there is another half. Cos theta equals to half. Cos theta is the x value, you know, from the unit circle. X value is the cos theta, y value is the sin theta. So you know half is at 60 degree. Then again this half you will get at 270, 300 degree. 270 plus 30. So 300 degree. So at these 2 points you will get this answer. But that's not the end, because see what is happening. If we, once we get the answer at pi by 3, which means that 60 degree, then if you come here, then you get the solution half. Then you again, if you keep rotating, again you get the 360 plus 60, again you get the value. Then if you come back again here, then you again hit the same point, that means another solution. Again you come here, that means another solution. Again you come here, then that means again another solution. So it means that you will keep getting the solutions again and again and again and again. And we understand it from the periodic motion, how many solutions it will come, because after every 360 degree there will be one solution. And there will be one solution from here. So it means that this is pi by 3. So at pi by 3 we have one solution. Then 2 pi plus pi by 3, there will be another solution. Then again 4 pi plus pi by 3, there will be another solution. This way solution will continue. and this will continue here also. This will continue here also. It means that at pi by 3, 5 pi by 3, there is one solution. Then 2 pi plus 5 pi by 3, there will be another solution. Just simply what I mean here is, just if you want to ignore all this, just you can think that since the period of sine and cosine function is 2 pi, after every 2 pi of these angles, there will be another solution, another solution, another solution, and it will continue forever. Because graph goes forever, that's why. So it said that finding all the solutions of the trigonometric functions, then actually we can write the whole thing this way. There will be two line of solution. One line for pi by 3. See this angle, same figure. I'm just discussing the same one. This another one is for 5 pi divided by 3. And then 2 pi k, this comes from the periodic property. We discussed it in our chapter 6, periodic property. Since the cos function and sine function, their period is 2 pi, so that's why 2 pi that thing is coming. And k is what? K is some number. Suppose k equal to 1, k equal to 0, k equal to 1, 2, 3, 4, 5, 6, 7. This way we will continue putting the value of k, and you can put the negative value also, because sine function, cosine function, they have the negative graph also. Like suppose this way it will go, it will go in the both direction. So this side is negative k, this side is positive k. So this way we can actually continue putting the value, and we will keep getting the values. If you put k equal to 0, then you get pi by 3 only. If you put k equal to 0, then you get 5 pi by 3 only, these two value. If we put k equals to minus 1 here, then we can do the calculation and we will get one value, then another k equal to minus 1, then we will get another value. So two values here. So, and then 1 we get this, 2 we get this, 3, if we put 3, then we will get 2 more values. If we put 4, we will get 2 more values. This way it will continue. Now you can ask, like, is it so then in the exam what we will do, how many values we will find? Generally in the exam always there will be some interval given. Suppose how much pi to how much pi, you have to do the math. This will be given in the question, like how many values you have to choose, then from the interval you will get the idea. So as a general picture, the objective of this math is to show you that for cos theta equals to half, this can happen many times. This is the thing. What is the conclusion of this question? It can happen infinite times, infinity number of times. Infinity is not number, but just for concept, we can say that this will keep happening. This will keep happening. So cos theta, and you can see that if you put the value of k here, 2, just only if we put 2, we get this 2 value, and from minus 1 to 2 we get all this value, then minus 3, minus 4, minus 5, all this we can put. By the way, can we put k value 1.5? Can we put it? Answer is no, because k has to be integer. K has to be some integer. K has to be some integer. K has to be some integer, that's why. And I have the picture why that is correct. I mean, why we said that there are many solutions. The reason is, if you look at the graph of cosine function, cos theta graph, this is the graph of cos theta, this graph, and half. Actually there is another way. This is another very interesting way to look at the solution. This is cos theta, this is equals to half. So actually we have two-part question here. We can think this question as cos theta equals y equals to cos theta. This is one way. Another thing is, we can think this question as y equal to half, left hand side and right hand side of the equation. So if you draw the y equal to half, this line, you get this line. And if you draw the graph of y equal to cos theta, then you get this graph, this curve, this cos theta graph. And the solution means all the points where they intersects. So you see here it intersects. So this is a solution, minus pi by 3, comma 0.5. So 0.5 will always be common there. 0.5 will be there always. Then you can see pi by 3. This pi by 3. See this pi by 3. And this is minus pi by 3. This is minus pi by 3. These 2 points. Then this is 5 pi by 3. This is 5 pi by 3. So at 5 pi by 3 also we have a solution. Then 7 pi by 3. We have 7 pi by 3 also. There is a solution. And from this picture you can see there is another solution here. There is another solution here in the negative side, and in the positive side also. I think you can imagine now there will be tons and tons of intersection this way. So this is a pictorial representation, it's a graphical representation or graphical proof that actually this question has many solutions. Solution means where both of them intersect. That is their solution. We can actually solve this math. If you have all these mechanism tools, then you can actually solve this math this way also. That also works. So let me go back and briefly talk about another thing. This one. So we said that when we have two values here, this will, I mean, we are discussing this thing now, so that it helps you if you start solving some questions from the exercise. This will help you. So this general formula, this is the general formula. This is the, see, there is give a general formula for all the solutions. So this is the general formula for all the solutions. We have two solutions here. One is at pi by 3, another one is at 5 pi by 3. That's why we have two equations. And this is the general formula. For sine and for cosine, formula is same. Just the angle will be different based on the math. If math is different, then this value will be different. Then 2 pi k will come for sine, cosine, both. Then for tan, it will be just only pi k, not 2. That 2 will not be there because the period of tan theta is pi. So basically, if sine, cos, tan, all the math basically is similar. This way is similar. Just the general formula will tell us where we have to go for finding the other solutions. Okay. And speaking of that solution, actually, I have more 3 videos here. You can click on this link or link. I actually created all these another 3 videos here. You can click on this link. Click on this link to understand how to solve more maths. Here in this video, I solved more maths from our exercise 7.3. Some questions from 7. I think 11 number. Or 30 number, this kind of math from our exercise. So if you want to see like how do we solve this kind of math step by step, then you can actually have a look on this math. In the class we will try to practice this kind of math I solved in this video. Okay, short video, they're like 6-7 minutes video. So and in the class we will try to practice some maths from here, and you also can give a try to solve some maths from there, so that in the class you can come with the specific questions. And that's all for today. Thank you all. Thank you very much. See you all in the class. Bye bye.